Okay, so first we will have this one, no? Ah, okay. Okay, so we first calculate the general lighting and convenience outlet load, no? So kung ano yung magiging demand ito, no? Okay. Okay, so for this one, so ito na-introduce ko tong table na to last time, no? Last week. So the table which is all about the types of occupancy and their number of volt amperes per square meters, no? So in order to compute, no, the lighting load and the convenience load, so first we need to know what type of occupancy ang ating i-consider. So we have here armories, banks, barbershop, church, churches, club, courtrooms, dwelling, garage, hospitals, hotels and motels, industrial commercial buildings, lodge rooms, office, restaurants, school, stores. Then we have warehouses, tapos any other, including assembly halls and corridors. Okay? So for this one, so madalas ditong i-ano talaga sa exam is yung sa mga banks, yung sa mga offices, then yung mga dwelling units, no? Yun yung kadalasan. So for the banks, we have 28 volt ampere per square meter. For dwelling units, it is 24. And for office buildings, so still 28, no, per 28 volt amperes per square meter. Tapos, ang gagawin natin the step 2 is to multiply the volt ampere per square meter to the floor area. So you see the floor area, that is the outside floor area of the building. So kunyari the area is 30 square meter. So we'll multiply 30. Kunyari bahay siya, so dwelling unit yan. So 30 times 24. And that will be now um, our demand load, no, for general lighting and convenience load. Yan. Okay, so let's have some examples. So what is the general lighting and convenience receptacle demand for a bank having a floor area of 120 square meter? So yan po yung hinahanap, no? Kung ano yung general lighting and convenience load, no? So dito, ang ating type of occupancy, okay? So the type of occupancy, so the type of occupancy is bank, no? Bank. Yan. So yung bank, so going from this table, so the bank is 28 volt ampere per square meter. So 28 volt ampere per square meter. Sa given naman, the floor area is 120 square meter. So the floor area is 120 square meter. So gagawin lang natin is to get the load, no? So we need only to multiply the VA per square meter to the square meter na ating floor area. So we have 28 volt ampere per square meter times 120 square meter, no? So we'll end up with the forward. So we have 28 times 120. So we have 28 times 120. That is equal to 3,360. Yeah, so that is 3,360 volt ampere. So, ang tamang sagot dito is letter C. Okay? Okay. So, let's have another example. Tapos, itry nyo na kayo muna mag-solve dito, no? So, we have, what is the general lighting and convenience load for hospitals having a floor area of 300 square meter? So, kunin ko lang dito yung hospital. So, that is 16. So, ito yung kaniyang volt ampere per square meter. So, 16. Yan. So, for hospital, so ang kaniyang per square meter, so hospital, so this is equal to 16 volt ampere per square meter. Yan. Okay. So, try nyo isolve yung general lighting and convenience receptacle demand load, no? So, yan. So, try nyo isolve. Tapos, paki-type ng answer nyo sa ating Google Meet chat box. Okay, so may nag-answer na po ng letter A, no? 4,800 volt ampere. Yan, tingnan natin yung iba kung ano yung sagot. Okay, so try po natin i-solve to, no? So the floor area now, no? Yung area natin is equal to 300 square meter, no? So para makuha yung demand load niya, so we have 16 volt ampere per square meter times 300 square meter. Yan. So our demand load now is equal to, calculate natin. So we have 16 times 300. So that is equal to 4,800. So 4,800 volt ampere. So yung tamang sagot is letter A. Okay, next. So you have general lighting and receptacle with small appliance and laundry circuit. No? So ito naman is where we're going to get the demand load if we have our appliance circuit, no? Small appliance circuit, TV, stereo, no? Yung mga fans, so this include a small appliance unit. Tapos yung laundry circuit natin, which is yung sa ating washing machine. So the step for doing this one is first, yung una natin ginawa, that is to get the general lighting and receptacle load, no? Yung kanina example natin. Tapos we will add 1.5 volt ampere per one small appliance circuit, no? Small appliance circuit, so maglalagay tayo ng 1.5, add ng 1.5. Tapos add din ng 1.5 for one laundry circuit. Tapos we'll use table 2.20.3 and apply the proper demand factor. So ito. So this is the proper demand factor for the lighting, receptacle, and small appliance laundry circuit. Okay. So for dwelling units, so yung first 3,000 natin, that will be 100%. So kunyari, yung total load natin, no, by using these steps, yung total load natin is 8,000. So yung first 3,000 natin, multiplyan natin yun ng 100%. So yung matitira, so 8,000 minus 3,000 will be 5,000. Yung 5,000, multiplyan natin yun ng 35, ng 35%, no? So if in case no magpass na siya ng 120,000, no, ganun kalaki yung demand natin. So yung sobra sa 120,000, we will multiply that one at 25%. Yan. Tapos hospitals, so ito din katulad no, yung first 50,000 na load, that is 40%, habang yung remainder, no, yung sobra sa 50,000, that is 20%. For hotels, 20,000, 50%, so on and so forth, no, kasama yung warehouses. Yan. Okay? So let's have an example para mas maintindihan. So we have determine the demand load for a dwelling having a floor area of 100 square meters with one small appliance circuit and one laundry circuit. Okay, so for this one solution, okay, so we have the floor area is 100 square meter. Okay, 100 square meter. Tapos uh, yung ating VA per square meter para sa dwelling, no? So galing dun sa table, that will be 24 volt ampere per square meter, no? So tingnan natin, i-check natin kanina dun sa ating table. Oops, yan. Ito, no? So dwelling unit 24 volt ampere per square meter. Okay. Yan. So kunin natin yung load, no? Yung load for our lighting and receptacle load, no? So for lighting and receptacle, so we have 100 square meter, that will be multiplied by 24. So volt ampere per square meter. So nagkakaroon tayo ng 2,400, no? Volt ampere. Tapos kapag mayroong isang appliance circuit, so one appliance circuit, so that is one appliance circuit, so 1.5 yan. So kunyari pag dalawa yung appliance circuit mo, so automatic you will add 3,000. Pero bawat isa sa kanila ay may separate na breaker. So ang nangyayari doon is yung dalawa tigwa 1.5 sila. Tapos one laundry circuit, no? One laundry. So that is another 1.5. So yung total nito is 5,400 volt ampere. Yan, no? 3,000 plus ano. Okay. So yung total natin na demand load natin, no? Demand load. So kasi dwelling unit to, from the table, dwelling unit, yung first 3,000 yan yung 100%. So yung ating 5,400, kunin natin yung 3,000 niya. So 3,000 times 100%. So yung 100% that is parang nag-multiply ka niya ng 1, no? Plus, so yung remaining sa 5,400, yung natira nung kinuha natin yung 3,000, so this will be 2,400. So tapos yung multiply natin to ng 35%, or that is equal to 0.35. Wala yata yung ano ko, screen share ko. So, isushow ko na lang muna ito yung calcu ko. Okay? So, yan. So, yung 3,000 po natin is galing po dito yan sa, sa table, no? So, yung first 3,000, yun yung kukunin natin sa total natin. So, kukunin natin yung first 3,000, saka i-multiply natin ng 100% or 1, no? So, kaya dito 1 yung ating multiply sa ating 3,000. Yung matitira, no? So, kasi itong 5,400 ito yung total natin, kinuha natin yung 3,000. So, yung matitira, 2,400, no? So, yan, i-multiply natin yan ng 0.35. At yan yung magiging demand load natin. Okay, so let's calculate. So, we have 3,000, no? Kahit hindi na ito i-times 1, sige, ganun pa rin yan, no? Kasi pag multiply natin yung 3,000 ng 1, so 3,000 pa rin. Times 0.35. So, yung correct answer is 3,840. So, tamang sagot dito is 3,840 volt ampere. So, that will be letter A. Okay? Next. So, determine the demand load for dwelling having a floor area of 150 square meter with one small appliance circuit and one laundry circuit. Yan. So, try nyo kayong mag-solve nito. So, same pa rin, dwelling unit. So, that is, for dwelling unit, the volt ampere per square meter is 24, no? 24 volt ampere per square meter. Pero bigyan ko kayo ng 3 minutes, no? To try to solve. So, ganun pa rin. Yung total, kunin niyo yung 3,000 from the total. Yun yung i-multiply nyo ng 100%. Tapos yung matitira, i-multiply nyo ng 0.35%. Okay. So, yan. So, let's solve this one. So, we have yung kanyang yung kanyang lighting load, no? Lighting and receptacle. So, this is equal to 24 volt ampere per square meter multiplied by the floor area, which is 150 square meter, no? So, equal to siya sa, oops, we have 24 times 150. Yan. Okay. Equal to 3,600, no? Volt ampere. Para naman sa ating appliance load, no? Appliance, small appliance load na isa. So this is 1.5 volt ampere. Tapos for laundry circuit, this is also 1.5. So we have 3,600 plus 3,000. So we have 6,600. So 6,600 volt ampere. So to calculate the demand load, so we have 3,000 galing dito sa ating 6,600 times 100% or times 1 lang yan, no? It's 1 plus, so yung matitira. So kinuha natin yung 3,000, so we'll have 3,600 na matitira. Then that will be multiplied by 0.35. Okay. So yung calculator natin, so we have 3,000 plus 3,600 times, mas pa lang 0, times 0.35. So we have 4,260. Yan. 4,260 volt ampere. So correct answer is letter D, no? So tama yung nag-comment or nag-chat ng kailang answer. Okay, next. So determine the demand load for motels having a floor area of 300 square meters with 5 small appliance circuit and 6 laundry circuit. Yan. Okay, so siguro 3 minutes ulit, no? For this one. For motels, no? Balik natin yung table. For motels, magpas tayo. So for motels, ang kaniyang volt ampere per square meter is 16. Yan, hotels, motels, so 16. Okay, so for motels, so this is 6,000 volt ampere per square meter. Okay. So 3 minutes. Okay. Natin if yung mga sagot nyo dito. Okay, so let's answer this one. So for motel, that is 16 volt ampere per square meter. So we have para sa kanyang lighting, no? So lighting and receptacle load. So we have 16 volt ampere per square meter times we have 300, no? So 300 square meter. Okay. Tapos the answer for this one is 16 times 300. Meron tayong 4,800. So 4,800 VA. Tapos meron tayong 5. So 5 small appliance. So 5 times, yung bawat isa kanila is tigwa 1.5. So we have, so 5 times 1,500. We have 7,500. So 7,500 volt ampere. Tapos 6 na laundry circuit. No? So laundry circuit, so that is 6 times 1.5. Okay. 6 times 1.5. This will be 9,000. We have 9,000 volt ampere. So ito i-add natin. Ito, tapos to 7,500 at 9,000. So yan magiging total natin. Total, ano, kita po forward. Okay, so we have 4,800 plus 7,500 plus 9,000. We have 21,300. So 21,300 VA. Okay? So, para makuha natin yung demand load dito, no? So hindi kasi ito katulad sa dwelling na dapat 3,000. So balikan natin yung table. Kanina, hanapin natin kung saan yung para sa hotels at motels. So dito. So mangyayari, yung first 20,000 pala is 50%. Tapos yung matitira is 40%. So ang ating load is, ang total load natin ay, wait, lumabas. So ang total load natin is 21,000. Yung 20,000 natin, yung multiply natin yan ng 50%. So 20,000 times 0.5. So that is 50%. Tapos yung matitira, no? So that is 1,300. 1,300 times 40%. So 0.4. Yan. Okay. So, ang answer dito, ito yung calculate natin. So we have 20,000 plus 1,300 times 0.4. So ito palang 20,000 ay dapat may times 0.3 times 0.5, no? So times 0.5. That is equal to 10,520. Equal to 10,520 volt ampere. So ang tamang sagot is letter D. Yan. Okay, yan. So letter D yung tamang sagot. Okay, yun. Let's proceed to the load calculation for clothes dryers. So yung mga dryer, no? So if our dryer is a separate entity, no, or separate unit, so ito yung gagamitin natin na ano, demand load, no? For the minimum VA for clothes dryer, it shall be 5,000 VA, no? So if in case yung nameplate rating ng clothes dryer is 3,000, ang gagamitin pa rin is 5,000. If in case lumagpas sa 5,000, so yun yung gagamitin na rating. Kunyari 6,000, so 6,000. Pero kapag 3,000, so ang gagamitin is 5,000. Then use the table 2.20.315 and apply the proper demand factor. So we have this one, no? So the number of dryers, so from 1 to 4, that is 100% demand factor. Kapag 5 na, so yung total, i-multiply na natin ng 85%. So 6, 7, 8, 9, 10, no? Tapos dito may special cases pag lumagpas na siya ng 23 at 43. Yan. So ang gawin natin ito is we are going to familiarize on how to use the table, no? So if ano pa naman, meron pa naman dalawang buwan, no? So you could familiarize with this one, no? So ito namang ano to, copy naman ito is i-send ko naman doon sa ating ano website, okay? Then let's have some example. So what is the demand load for 4 kilowatt household clothes dryer? So ito lumabas to sa mga nakaraan na ano exam, no? So what is the demand load for a 4 kilowatt household clothes dryer? So 4 kilowatt. So kung babalikan natin sa sinabi ko kanina, so if that is 4 kilowatt, 3 kilowatt, or ilan ba yan? So yung 4 kilowatt is 4,000 watts. So ang pinaka minimum na gagamitin for clothes dryer is 5,000. So dito, ang tamang sagot dito is 5,000 kasi hindi siya umabot sa minimum. So kaya 5,000 yung gagamitin. Okay, next. What is the demand load for 8 4.5 kilowatt household clothes dryers? Okay, For this one naman, no? Solution. So, ang gagamitin natin is kasi 4.5 kilowatt yan. So, ang gagamitin pa rin natin na value is the 5,000 VA or 5,000 watts, no? Kasi bakit yung 5,000 watts? Kasi ito yung pinaka minimum, no? Hindi siya umabot sa minimum eh. So, gagawin natin ngayon to solve for the demand load. So, we have 5,000 VA. Tapos, ilan sila? 8, no? So, times 8. Tapos, i-multiply natin kung ano yung percent doon sa ating table kanina. Yan. So, 8, that is 60% times 0.6. Yan. So, 5,000 times 8 times 0.6. So, that is 24 kilowatts. So, we have 24 kVA, no? Or 24,000 VA. So 24,000 volt ampere. So the correct answer is letter B. Yan. Okay? Okay, ito. So find the demand load for 25 8,000 volt ampere cloth dryers. Yan. So siguro will give you 5 minutes no to answer. Ito. Try nyo, no? So nandito yung table. So ito yung given na na load. Tapos kung ilan siyang piraso. So 25. Okay. Yan. So let's solve this one, no? So meron tayong 25, no? 25 na dryers, no? So 5 times 8,000 per dryer. 25 times 8,000 have 200,000. 100,000. Okay. Tapos yung percent demand for 8 is only 60%. So you have 64.6, no? So we have 200,000 times 0.6, 1,200. Load for this one is only 1,000, 120,000 volt. Ito yung ating answer. Okay? Then we have load calculation for ranges. No? So for this one, we use the table 2.20.316. Choose among column A or column C to the proper demand factor. So in case two columns are applicable, hanapin natin kung ano yung lower value. Okay? So ito yung mga table, no? So we have column A, so it is from less than 3.5 kilowatt rating ng ranges. Yung B naman is from 3.5 to 8.75 kilowatt. Yung column C is the maximum demand, no? Depending on the number. Pero hindi siya pwedeng mag-pass ng 12 per range. Yan. Okay, so what is the maximum demand for an 8.5 kilowatt range? Yan. Ito, 8.5 kilowatt. So ito, it will fall kasi natin yung column. No? 8.5, so it will fall in column B. Column B, so 80% mo ating demand. times 0. So this is from, okay. So 8.5 times 0.8, that is 6.8, 0.8 kilowatts. If you are going also to have column C, no? Column C, that is column C, 8 kilowatts. Yan. Ito, bali ito is per, ano to, kilowatts to. So, kunyari, isa lang siya. Tapos, hindi siya lalagpas ng 12 kilowatts. So, ito, gamitin. So, 8 kilowatts. So, from column C, 8 kilowatts. So, alin dito yung pinakamababa? Yung pinakamababa yung ating gagamitin, which is the 6.8. The correct answer is letter A. Okay, next, no? So, 19 na 8.5 kilowatt ranges. Okay, for this one, I'll give you siguro, no, 10 minutes, no? So, be back at 9 para i-solve to. You could solve also on your side, tapos i-send nyo lang sa ating chat box, no, kapag na-solve. So, at 9, ano, 9 p.m., so, solving this one. Kung ano yung tamang sagot ito. Okay? Okay. Yan. So, balik po tayo. So, we will be solving this one. So, what is the demand load for 19 8.5 kilowatt ranges? Okay. Solution. So, 19 siya, no? So, we'll have 8.5 times 19 kilowatts. Okay, so this will be equal to, saan yung kalagay ko dito? So, we have 8.5 times 19. So, meron tayong 161.5, no? So, we have 161.5 kilowatts. Okay? So, tingnan natin sa table kung ano yung demand for percent demand for 19. So, 19, so this is 28%. Okay. So, ito, mangyayari dito from column B sa ating table. So, we will multiply this one by 0.28. Ito kasi yan yung 28%. Okay, so times 0.28. So, it will become 45.22. Yan. So, 45.22 kilowatts. Tingnan natin sa column C kung mas maliit ba sa column C yung value ng ating 19 na 8.5. So, column C, so 8.19, so this is 34, no? So, 34 lang siya. So, yung susundin natin is yung pinakamaliit from column C, which is 34 kilowatts. So, ito yung tamang sagot. Okay? Okay, next we have motor load calculation. So, ito yung pinaka-common din sa, when it comes to PEC calculations sa board exam, yung motor load calculations. Okay, so in determining the motor load calculations, kung ano yung kukunin natin. So usually kukunin natin is the ampacity of the wire and the setting of the overload relay or the circuit breaker. So for the setting of the overload protection, so ito yung mga percentage. So if the service factor is given kapag 1.15, so 140% times the full load current, no? Tapos kapag yung temperature naman sa nameplate is 400 degrees or less, so 140 din. All other motors na hindi papasok sa dalawang condition na to, that is 130%. Kapag separate, tapos more than 1 horsepower yung ating overload protective device, 125% for the service factor 1.5 or greater or 40 degrees Celsius or less na temperature rating. All other motors is 115%. Okay, so yung branch circuit natin, yung ampacity ng wire, so that is 1.25 times the full load current of the motor. Yung sa branch circuit naman na gagamitin, yung overcurrent device, yung breaker or yung short circuit protection natin or gun fault protection, nakadepende kung anong klase yung gagamitin natin na device. So if that is a non-time delay fuse, a dual element delay fuse, it is a strip breaker or the inverse time breaker. So kapag single phase, ito yung kanyang mga percent na ita-times natin sa full load current. So may tayong single phase na AC pala, AC na fully phase, squirrel cage, depending on the type of the motor. Meron siyang sariling percent na ita-times sa full load current. So paano makukuha yung full load current? So either that full load current is found on the nameplate or sa table na binigay ng Philippine Electrical Code. So table na makikita sa Philippine Electrical Code. Usually naman, if medyo generous yung gagawa ng exam, so ibibigay na lang mismo yung full load current. Yan. Okay. So we have here, So 1 horsepower, 230 volts single phase motor with a service factor of 1.15. So we need to determine the overload protection of the device. Yan. So kunin natin yung table. Yung table dito. So the motor is a single phase, single phase motor. Okay, so ito single phase. Kopya ko na lang to para makita doon sa sa ating screen. Okay, yan. So we have a single phase motor, Service factor 115, tapos 230 volts. Hanapin natin yung setting ng overload protection. So we have 1 horsepower. So dapat ito 1 horsepower, 230 volts. So ito yung kanyang full load current, 8.0. So yung ating FLC natin o the full load current based on the table is 8.0 amperes. So to get now the setting of the overload, so yung service factor niya is 1.15. So this will be equal to 140% times 8 amperes or 8.0 amperes kasi ito yung full load rating niya. So using our calculator, so we have 140, that is 1.4 times 8. So the answer is 11.2. Yan. So 11.2 amperes. So ito yung answer. Now for this one, kita yung last choices. So maybe ang overload protection device nito is separate. So if separate yung overload protection device, so this will be 125%, no, 1.25. So i-try natin pag 125 kung meron bang papasok dito, no? So FLC natin is equal to 8.0 amperes. So yung OL, so for separate device, this is 125% times 8.0 amperes. Okay, so we have 1.25, that is 125% times 8, so 10. Yan. Okay, so 10 amperes. So the correct answer dito sa ating choices is letter B, which is 10 amperes. Okay, next we have for a 1 horsepower 230 single phase motor with a service factor 115, so we need to determine the branch circuit and the ground fault current device. So hinahanap dito is yung size ng breaker. Okay, solution. Okay, so for this one, so we need to find first the FLC. So katotong kanina, the FLC or the full load current is 8.0 amperes. Tapos yung kaniyang ano ba yun? Yung kaniyang percent, no? Percent for the protection device, no? So ayan, doon natin kukunin yun sa table. So if we are going to use an inverse time circuit breaker or instantaneous, so ito inverse time circuit breaker ang gagamitin natin, so that is 250% for single phase motor. Yan. So mangyari dito is we need to multiply. So yung ating percent is 250%. So our short circuit breaker now, no? Or the circuit breaker rating is equal to 8.0 amperes times the percent, which is 250% or 2.5 yung value. So we have, so 8 times 2.5, so that is equal to 20. Yeah, so 20 amperes. So ito yung ating tamang sagot, which is letter A. Okay? Yan. Okay, so how about if hahanapin dito is ampacity? Yan. Hanapin natin yung question dito about ampacity. Okay, so ito. For a 1 horsepower 230 volt single phase motor with a service factor of 1.15, determine the opacity of the branch circuit conductor. Yan. So kapag ang opacity, ang i-multiply nyo is 125% or 1.25 doon sa full load current. Okay? So siguro 3 minutes to answer this one, and kindly put your answer on our chat box. Okay? Okay, yan. So let's answer this one. Okay, so yung ating FLC is ganun pa rin. FLC is equal to 8 amperes kasi same motor lang siya. Tapos, to get the branch circuit, no? Branch circuit conductor. So we have 125% multiplied by the FLC. Yeah. Okay, so we have 8 times 1.25. So the correct answer is 10. So we have 10 amperes. Ito po yung tamang sagot. Yan. Okay. Next, we have ampacity calculation. So ito na po yung para sa mga wires, no? So there are two tables na gagamitin. The adjustment factor, which is kung ilan yung nakalagay na wire sa isang tubo, no? So itawag to is the derating factor. So if ang isang tubo, mayroon na siyang more than 3 wires na nakalagay doon. So magkakaroon na siya ng derating. So for more than 3 current carrying conductors. So ibig sabihin hindi kasama sa bilang yung ground, no? Kasi hindi nakikigari ng current at yung neutral. So if kunyari may tatlong or apat na current carrying wire sa isang tubo, so kakaroon na yan ng derating. So from 4 to 6, 80%, from 7 to 9, 70%, from 10 to 20, that is 50%, 21 to 30, 45%, 31 to 40, 40%, and 41 and above is 35%. Yung isa naman is all about the temperature. So our tawag doon, our wires are rated on different temperature, no? So 60, 75, and 90 is the usual temperature rating. If in case nagbago yung temperature, no? So kunyari naging sa 60 tapos yung temperature na paggagamitan natin is only 15. So ito yung i-multiply natin sa ampacity, no? So either this will be the magtataas yung ampacity niya depending on the temperature or bababa if we are going to use the wire on a temperature na mas mataas sa kanyang temperature rating. Okay? So yan. So steps, so apply the wire opacity by using the three tables. Then use applicable adjustment factors and the correction factors in terms of the temperature. So ano naman, table for the wires. Siguro ipi-paste ko na natin dito. Ano yung wires dito? Okay. Yan. Ito. Yung sa derating o yung doon sa ampacity or current carrying factor ng tawag doon, ng mga wires is only applicable kapag yung wire nyo is nasa loob ng tubo, no? So it is not applicable if your wire is exposed. Yan. Okay. Okay, so ito yung table, no? So this is for wires inside a raceway, cable, or earth. So the cable rate, which is not more than 3 current carrying conductors, no? So ito yung conductor size natin, yung size ng wire. Ito yung type ng wire. Tapos kung saan itong sa baba is the ampacity. No? So we have two types of wire for premises wiring or the wire which is applicable for PC part 1. We have the copper and the aluminum or aluminum alloy na wire. Okay? So for this one, okay, so ang kailangan lang gawin is to find what is the ampacity of the wire. Kunyari 2.0 THHN. So ito 2.0 THHN copper. So 25 amperes. So 25 amperes ang kanyang ampacity, no? So i-apply natin kung ano yung applicable na mga adjustment factor. Yan. Okay. So ito ulitin ko lang. So this table is only applicable if your wire is inside a raceway or a conduit or directly buried. No? Kapag exposed siya, so hindi no need to apply this adjustment factor. Yes, so nakadepende po sa klase ng wire yung ampacity. No? So if your wire is a THN, so mas mataas yun ang ampacity compared to a TW or THW na wire. Yan. So ito yung pagbabasihan na table. So kunyari, THW na 2.0, so 20 amperes yan. Pag TW, 15 amperes. Kapag THN, 25 amperes. Pag copper. Iba din yung ampacity when it comes to aluminum kasi wala pong aluminum na 2.0 na kahit anong klaseng insulation pa yan, wala pong aluminum na 2.0 ang size, no? So ang aluminum, it will start on 3.5 square mm. Okay? So let's have this example. So find the opacity of 22 square mm THWN for not more than 3 current conductors in a raceway at 30 degrees Celsius. So ang nilagay nito, hindi siya magpa sa tatlo. So ibig sabihin, the first table na pinakita ko kanina is not applicable, pero ginamit siya at a lower temperature at 30 degrees Celsius. Okay, so hanapin muna natin yung ampacity ng 22 square mm THWN. Yung ampacity niya doon. Okay, yan. So, ano ba to? Copper ba nakalagay? Okay, so if in case hindi nakalagay na copper, so sa tanong, so you always assume na copper kasi yung pinaka-common na ginagamit, especially on interior wiring, is copper. Okay, so 22 square mm. So, hanapin ito 22 tapos THWN. So, ito, THWN. So, 22 THWN, that is 85. Yan. So, ang ating opacity is equal to 85 amperes. Pero ginamit siya at 30 degrees Celsius. So, balik tayo sa isang table. Yan. So, ito. So, itong bababasihan natin is kung alin dito yung temperature rating. So, the normal temperature rating for THWN is ito, 75. Yan. So, kapag yung wire nyo is may isang yung edge niya. So, this is usually denotes as 25 degrees Celsius. Yan. Yung TW, that is 60 degrees Celsius. Yung UF naman is that is underground wire or underfloor wires, no? Okay? So, it is 75, no? So, 75 dito, 30 degrees siya ginamit. So, ang multiply mo lang natin is 1. So, 1 na yung multiply. So, yung magiging sagot pa rin is 85, no? Okay, so the adjustment, no? So, 85 amperes times 1. So, ito magiging 85 amperes. So, the correct answer is letter B. So, if in case po na hindi nyo ma-memorize yung table, so just kapag yung wire naman kasi sobrang laki na, so binibigyan niyo yung ampacity, no? Tapos ang na lang is you must be able to familiarize kung ano yung gagamitin na adjustment factor at correction factor. Okay, so ito, we have find the ampacity for 22 square mm THWN for not more than 3 current conductors on a raceway at 25 degrees Celsius. So 25 degrees Celsius po yung temperature rating. So try nyo po, no? So siguro 2 minutes, no, to answer this one. So ito is copper, no? Copper yung isa. Okay, so let's answer po this one. So we have, ano pa rin ito yung kanyang ampacity, no? 85 pa rin. 85 amperes, no? So not more than 3 carrying conductors, so hindi po mababago yung ating tawag doon. Yung ating adjustment factor nito, doon po lang po tayo sa function factor in terms of temperature. Kasi ginamit siya 25 degrees Celsius. Okay. Pag sa table, sa temperature, so THWN 75. So kapag 25, so multiply natin ng 1.05. Yan. Okay, so we have the corrected or the adjustment, no? Ampacity will be 85 amperes. Tapos galing sa table 1.05. Yan. So we have 85 times 1.05. This is equal to 89.25. So 89.25 amperes. So correct answer dito is letter C. Okay, next. So find the ampacity of 22 square mm THN for not more than 3 current carrying conductor copper, no, in a raceway at 45 degrees Celsius. Okay. So for this one, ganun pa rin yung ating ampacity, no? The ampacity, kasi pareho lang yung wire sa ating example. So 85 amperes. In case 30 to, so mababago din yung dito, yung ampacity. Tapos ang kanyang degrees Celsius is 45. No need to use the adjustment factor kanina kasi hindi naman siya lumagpas ng 3. So balik tayo doon sa table, all about the correction factor sa temperature. Okay. So we have 45 degrees. So 0.82. No? Multiply natin siya ng 0.82. 41 to 45 degrees. Yan. Okay. So we have, so the adjustment now, we have 85 amperes times 0.42. Kita mo yun, check ko lang. Baka kamali ako sa value. Plus 0.82 pala, hindi 42. 0.82. Okay. So we have 85 times 0.82. Is equals to 69.7, no? So 69.7 amperes or 70, yung pinakamalapit, 70 amperes. Okay, next. So the ampacity of 2.0 square mm THW conductor when there are 6 conductors in a conduit and the temperature is 30 degrees Celsius would be blank in amperes. Okay, so try nyo to, no? We'll give you 3 minutes, no, to answer. So ito magagamit niyo yung first na table which is all about the rating factor. So 6 yung conductors na nasa loob ng raceway. Okay, yan. So nilagay ko na yung mga table, no, na pwede nyong magamit. So yung 2.0 na square mm THW, okay, so that will be, yung ampacity niyan is 20 amperes, no? Per table nung kanina sa table dito. Yan. So THW 2.0, so 20 amperes ang kanyang ampacity. So pakilagay po ng answer niyo sa ating chat box. Okay? Yan. Ang kanyang ampacity is 20. Capacity is 20 amperes. Okay. 2.0 THW. Tapos, 6 conductors. So, yung 6 that is 80% for the assessment to is 80%. Habang yung temperature 30 degrees. So, THW this is 75. 30 degrees is 1. Fractions is 1 for the temperature. No? We have now getting the adjusted, no? Adjusted capacity. We have 20 amperes times 80%. So that's 0.8. Tapos times 1, which is corrected. We have 20 times 0.8, so that's 15 amperes. 20 times 0.15 amperes. Yan. That will be letter A. Letter A. Yung tamang sagot. No? Kasi consider natin yung 6 conductors. Okay. Yan. So that will be all for this session. Hope na you understand something about load calculations. So, ayaw po naging maliwanag sa inyong lahat. So, in case po may tanong kayo, tapos gusto nyo pang i-ano yung tanong nyo, so you could have that one on our GC, our group chat, no? Para maano din natin, no? Maklaro natin kung ano yung mga tanong. When it comes naman dun sa last topic natin, so mayroon na po tayong practice test na nakapost na po sa ating mga website. Yung iba is nasa GC, so you could answer that one. Tapos I'll be posting also siguro 25 problems, no, about this one. No, for the soft copy, nandun din po sa GC at doon po sa ating group chat. Okay? So, just download po yung ating mga soft copy. Tapos yung recorded naman po is available na din po yung ating recorded sa website at sa ating group chat. Okay? So, I hope klaro po ang lahat, no? So, meron tayong tingin ko dalawang session na na-miss, no? So if okay po sa lahat, we will have a make-up section during Saturday po, no? Same time po, no? Yung ating make-up if okay po sa lahat. So we just be sending a announcement, no? If when will be the make-up session, no? Every Saturday po yung magiging make-up session natin. If in case po hindi kayo makarating, of course, meron pa rin po yung ating recorded na mga discussion. Okay? Okay, so thank you for joining this session. I hope you will have a nice night ahead, no? At yung mag-apply na po for the exam, so kindly do so, no? Kasi may March 12 yung deadline, no? Para hindi po kayo ma-close po ng deadline. Okay? So thank you and have a pleasant night ahead. So you can now leave our Google Meet session.